Well, hello, I'm Jennifer Reece, and I work for HP as a Principal Program Manager in our Global Product Compliance and Sustainable Impact team. I've been at HP for over 27 years and in sustainability for almost 13 years now. I started at HP as a manufacturing engineer in our enterprise storage division and worked in reliability and quality for inkjet printer development. I've led several programs in sustainability, mostly related to sustainable materials, and that includes the EU REACH regulation and other substance disclosure reporting requirements, packaging regulations. I helped to create and implement HP's zero deforestation goal, and also same for our 75% circularity goal, helped to create and implement that. I'm currently the Pan-HP PFAS program manager, among a lot of other responsibilities. And one of my colleagues, Kevin, just showed up, who helps me with all this work. I appreciate the opportunity to share with you today a few things, including an overview of HP's sustainable impact strategy, our work in circularity and sustainable materials, and a deep dive on the PFAS program. Okay, make sure this works. Uh-oh. Am I doing this right? It's not changing. Let's see. There we go. Okay. Okay, so sustainable impact is a business imperative for HP, our partners, and our customers. HP has long been a purpose-driven company. It's integral to our culture and has made us one of the world's most sustainable or most trusted brands. We continue to invest in sustainable innovation. We believe it will help future-proof our business by staying ahead of changing regulations while continuing to meet customer demand. There we go. At HP, our bold ambition is to lead the future of work, delivering growth and fulfillment for business and people everywhere. So this is a new kind of strategy we released with our 2024 Sustainable Impact Report. And it's informed by our active stakeholder engagement, global sustainability contexts, industry partnerships, and our materiality assessment, as well as external frameworks. And we see responsibility to lead the path ahead. So you can see from the slide, our strategy includes 3 pillars that include empowering customers to lower their environmental footprint with HP innovations, transforming HP's value chain by driving resiliency, responsibility, and sustainability, and advancing societal impact through digital equity and workforce development. Sustainable impact is also a key differentiator as well as a business imperative. In 2024, our revenue from products and services that helped reduce environmental and social impact was more than 60% of our total revenue. HP is recognized as one of the world's most sustainable companies. And this gives you an idea of some of those recognitions, and I'll just speak to a few of them. So Newsweek ranked HP in the top 10 for ESG performance. We were ranked in the top 10 on Forbes Net Zero Leaders of 2025. And Trust & Sullivan recognized HP as the 2025 America's Company of the Year for leadership in sustainability and the circular economy. Getting into our circularity work a little more. So through innovative products and services, we're progressing toward a fully circular economy. We set a goal in 2021 to achieve 75% circularity in our products and packaging, which includes recycled and renewable content, as well as reused parts and products. So across our portfolio, we're creating the transformative and disruptive technologies of the future. We continue to apply rigorous design principles to significantly enhance our environmental performance of our products. And I won't speak to everything on the slide, but talk about some of our design priorities, working on increasing the use of recycled and renewable materials in both products and packaging, practicing responsible chemistry, which I'll go through in more detail in a few slides, and enhancing product repairability, reusability, longevity, and recyclability. One thing I want to mention is I'm not covering our carbon reduction goals in this presentation. It's important, though, to note that we do have several goals, including 100% renewable electricity in our operations, and then achieving net zero emissions for our whole value chain by 2040. And the circularity work directly supports that. So especially if you're thinking about enabling product longevity, repairability, and reusability, that contributes a lot to reducing our carbon footprint. This slide gives a few product examples that we've done to innovate for sustainability. So I'll just mention a couple of them. We have our notebook PCs have a lot of good proof points in this area. So the Elite Book that's mentioned here contains at least 80% recycled aluminum, 30% ocean-bound plastic, and there's the heat plate has at least 50% recycled copper. The keycaps are made with at least 50% recycled plastic, and it's also registered under the eco label that's EP Climate Plus Gold in the US. And something else I want to mention that's not shown on the slide is we have incorporated a lot of renewable content in our products and packaging. And for products, what we're doing is including biofeedstocks to replace petroleum feedstocks. And that's mixed in, at the kind of chemical level so that it creates the same resins that we already use. So that's something that's, a good innovation we've done over the last several years. Also shown here for print is the LaserJet 8000 series, which is designed to meet EPEAT Gold and Energy Star criteria. And for the first time, it includes certified recycled metal in the chassis parts. So another program we've worked on is for our HP toner cartridges, we have what's called TerraJet technology, which is where the toner melts at a lower temperature, and it allows the cartridges to be 30% smaller. We also use up to 35% recycled content, and it reduces our energy consumption by up to 27%. Okay. This slide talks about packaging innovations. So our circular packaging strategy centers on eliminating unnecessary and hard to recycle packaging material, using packaging materials with higher recycled content, especially for paper-based packaging, and then prioritizing easily recyclable or recycled packaging materials. We set a zero deforestation goal in 2021, in 2016. That was, the time that there was a lot of goals being set by companies, especially in the deforestation space. HP sells HP brand paper, so you might wonder why electronics companies set a goal in this area, but it's because we have a big portion of our footprint is our paper we sell and the paper that goes through our printers. So we achieved that goal in 2020, and what that meant was we required any paper-based packaging to be either derived from recycled or certified content. And I helped manage that goal, so it was something that we managed over 4 years and started with almost no information on where we were at. There's a lot of recycled content already in packaging, but over time was able to get the materials, any virgin materials certified, preferably to the Forest Stewardship Council standard. We also set a goal to reduce single-use plastic packaging by 75% compared to 2018 levels. And we've been shifting away from packaging made from plastic-based foam, and other hard-to-recycle materials in support of that. One example from 2024 is we shipped 58 million units using 100% molded pulp cushions. And that helped us reduce our expanded foam by over 1,100 metric tons. And then wanted to just speak for a minute about how we've been able to set ambitious goals and achieve so much. I think, obviously we have to start with the business case. It's showing how this work will support the customer needs. And as I mentioned, 60% of our revenue is due to sustainability, or those deals that have some sort of sustainability requirements. So starting with that business case is important. Also getting ahead of regulations is key. And that's something that we've been able to make that case, as well as we work with organizations setting requirements and building them into market access requirements like eco-labels, and actually have advocated for them to include certain things, because that's how we can really move things forward. Also, with our suppliers, setting specifications that are reasonable for our suppliers to achieve to start with. Start with like signaling to them that we're moving in a certain direction. They need to start thinking about these things. They need to start thinking about getting packaging certified or increasing recycled content that's available. And then, really working with them on capability building programs and, bringing them along on our journey. So we think collaboration is really key with both our suppliers and other companies. So we're not burdening our suppliers with something different that other companies aren't asking for. So that's really a theme throughout a lot of work we do. So responsible chemistry is a big part of our sustainable materials program, and I have a lot of experience in this space. Most of my career in sustainability has been in this space. So for over 3 decades, HP has actually worked to shift the whole electronics industry away from chemicals of concern to safer alternatives. We began our work in 1992 with the launch of our Design for the Environment program, and created what's called our General Specification for the Environment in 1998, and that includes not only regulatory substance restrictions, but proactive restrictions as well. In addition to proactively restricting substances, we've collaborated with many stakeholders to solve the difficult challenges of trying to find alternatives for certain materials. So this has included work on brominated flame retardants, phthalates, and PVC. We also, many years ago, worked with the EPA and Clean Production Action to create a standardized method for evaluating the human health and environmental impacts of substances, which is the foundation for Green Screen for safer chemicals, if any of you are familiar with that. And we were the first corporation to adopt Green Screen as well. HP was also a founding member of both the Green Chemistry and Commerce Council, which is now Change Chemistry, and the Clean Production Action's Biz and Geo Working Group, which we're still active members of. We've also contributed to standards, eco-labels, and legislation to ensure they align with environmental benefit. For example, including a preference for safer alternatives to avoid regrettable substitutions. And finally, we contributed to the development of the National Academy of Sciences Alternatives Assessment Framework, and we've aligned our process to that. Okay, it's time for PFAS. So if you're not familiar with PFAS, then what it stands for is per and polyfluoroalkyl substances. They're a group of about 5,000 chemicals used in a wide variety of consumer products and industrial applications. And they have really unique chemical and physical properties, so they can accomplish a lot of different functions and performance that is needed for a lot of our technology. But they are pervasive, environmentally problematic, and they may lead to health effects. It's likely used in every electronics product. We've confirmed that pretty much for HP's products. So it's no big secret, it's used everywhere. And eliminating it is a big challenge for the industry that will require sustained focus over multiple years. So this slide shows the most common uses for electronics. I'm just checking time. So some key uses include, I won't go through all the uses, but PCAs can be found as a flame retardant and dielectric insulator. Semiconductor manufacturing applications, including etching and other processes. In the liquid crystal display structure, as well as for dust and static protection and anti-fingerprint coatings on display panels. It's also used as an insulating material in cables and power adapters. Batteries as a cathode binder, separator, and electrolyte, as well as in the plastic enclosures. In plastics for anti-drip flame retardancy, and it's also used in plastics for anti-wear applications, especially in printers. But there's other places it's used, not just printers. Lubricants and greases for resistance to wear and moisture. And then adhesives to increase wettability and penetration. So it's used everywhere, mostly in the fluoropolymer forms. A lot of PTFE is used. Oh, I need to go to the next slide. Okay, so what are the drivers? There are increasing PFAS regulations that include the EU Universal PFAS restriction that will apply to electronics and include fluoropolymers. It's likely going to take effect in 2029, which I'll cover more in the next slide. There's also reporting and disclosure requirements, including the Canada reporting that was due last July. There's the Minnesota reporting requirement July of 2026. And then the US EPA Toxic Substances Control Act, or TSCA, has a reporting requirement in October of 26. There's also several US states restricting PFAS for different uses, and they may include electronics in the future. There's one in New Mexico right now that's signaling that they're going to restrict PFAS in all printers, at least, if not other products, by 2032. And then there's market access requirements. So I mentioned eco-labels. EP is an eco-label I'll talk about a little more detail in a couple slides, but they have several optional criteria related to reporting PFAS usage and removing it from products and packaging. And that's something that's, EP is required for several government deals. So I'll go into that eco-label in a few slides. There's also competitive pressure, which could increase with the EP eco-label launch that's about to happen. And there's potentially going to be competition over securing a supply of the alternatives too, because they won't be widely available to start. Retailers are also beginning to phase out PFAS for certain applications, so that puts pressure on companies that sell to them or sell through them. And then some suppliers are beginning to phase out production and use of PFAS, which could lead to assurance of supply issues. So the EU, like I mentioned, has been regulating PFAS for many other applications. And they've been focusing on kind of more where there's more exposure to consumers, but they're signaling with their universal PFAS restriction that they will include electronics. And so what I manage is really focusing on the hardware that we sell and the PFAS usage in those. There's also work already being done for our inks and other applications. So we think it'll take effect in 2029. There was an updated background document released this last August, and that considered over 5,000 comments from multiple industries, but especially the electronics industry was big in that. Those comments were really giving feedback on the regulation and the difficulty of finding alternatives mostly. And there's some information. This background document is hundreds of pages, a lot of good information there. But there's many proposed derogations, which are time-limited exemptions. So those derogations are for many applications used in electronics, but not for everything. So they are either 5 or 12 years from the implementation date. So that'd be starting in 2029. But there are some applications that don't have a derogation. So there's capacitors and some other electrical components. There's some plastic additives, and then sealing applications aren't included. So there'll be advocacy over the next few months to provide feedback on all of the applications and the possibility of finding alternatives, and hopefully will inform their decisions. The comment period goes, I think, until March, and then the REACH committees will take that feedback into account, and then we expect the final rule to be published around December of 2027. So it's still a little time before it's finalized, but it's certain that it's going to happen. There's no doubt. There's almost no doubt, I should say. And then one thing that's important to know is there are reporting and labeling requirements with this regulation. that will include, especially for any derogations being used, for the longer derogations, you have to actually report what's being used and label products that they contain PFAS. So HP is a worldwide company, so the EU drives a lot of our work in this space, and it's quite important that we have formed a program team to really manage that. So EP, like I mentioned, it stands for Electronic Product Environmental Assessment Tool, which even some of us forget sometimes what that stands for. But it's a program that provides a framework for the environmental assessment of electronic products. It was developed to help purchasers make informed decisions about the products they're buying and the environmental impact of those. They evaluate products based on various criteria, and the specific criteria could vary depending on product category, although there are some common criteria for it. EP includes required criteria that you have to get to achieve bronze level, and then there's optional criteria where you can add up the points to get to silver or gold. And they're revising it right now. It's been a long process. It's about to launch. And they're including several points for gathering data on PFAS usage and also restricting PFAS or removing it from products. They're all optional, but it is driving a lot of our work because it's something that we can go after some of those points that might be less costly than some other criteria they have. Okay, I'm getting close to the end. So like I mentioned, we do have a pan-HP PFAS program that I manage. It includes our procurement business unit partners as well as our product stewards. There's about 60 people involved, although it's very much part-time for everybody, even me. So it's not like we're spending all of our resources on it. And this slide shows our high-level plan that includes the regulatory and market access requirements across the top, like I discussed. And then you can see our key work streams. It's very high level. We have a very detailed plan in a smart sheet, but this includes advocacy for regulations, and then gathering data on PFAS usage, identification of safer alternatives, and then qualification of those alternatives. So I'll talk about some of those in more detail. So HP is very transparent about some of this work because, like I said, we know PFAS is used in all electronics. It's not like it's just our products. So some people are surprised we share this level of information, but that's why we think it's important to share. And you can see the data here is for personal systems, so that's like PC and display products. And we've been gathering data through our existing substance disclosure processes that we already have, that we do for regulations and market access requirements. But then we've been supplementing it with a representative product approach where we, in particular for PFAS, we have represented products from each product category. And then that list I showed of the high-risk components to contain PFAS, we're trying to make sure we get full data for all those. So that's how we're approaching it, and that's how we're doing our reporting as well, which some people might wonder, how do you report for like the Canada reporting last July? Well, we did it based on represented products. I mean, we ship thousands of different SKUs, so we can't gather data on all those easily. So you can see some of the top uses for personal systems here. So in the LCD, well, I don't know if you can read that, but LCD panels, monitors, keyboards, PCAs, microprocessors, capacitors, power supplies, and batteries are kind of some of the key uses. And then for print, I need to switch slide. Some of the top uses for printers include lubricants, connector assemblies, plastics, capacitors, labels, microprocessors, and PCAs. And this isn't a full data set, but it shows what we've gathered so far. Okay. So really the way we're searching for alternatives to begin is asking our suppliers if they already know of potential alternatives. And it's kind of more targeted, not like we have a separate process to gather full PFAS usage. And part of that is moving toward full material disclosure as well. But this is more targeted to ask suppliers, if you're using PFAS for these applications, do you know of alternatives? And if there aren't known alternatives, then obviously we're going to have to, as an industry, do research and collaboration. Then the alternatives are reviewed against our sustainability criteria, in particular looking at the hazard ratings and taking into account any exposures to customers or the environment. If the chemicals have unknown hazards, then we have chemical hazard assessments performed. And then if the hazard ratings are acceptable, then our R&D teams are beginning to do some preliminary evaluations and qualifications of those. So we've already began that work, but it's just the tip of the iceberg. There's so much more to come on that. Okay, and then the last main slide. So as I mentioned, we believe collaboration is key to really solve any challenges related to sustainability, but in particular for replacing PFAS. And if you're not familiar with Chem4, they're an organization that has a database to share information on chemical hazards. So it's a shared repository, and they also have working groups to focus on finding safer alternatives. So there's been some for flame retardants, and they don't just work in electronics. They have several collaboratives, like in the textile space. And then there are, pre-competitive working groups. So, you can see some of the companies involved. HP is sponsoring their working group on PFAS. So we are sharing information on alternatives we're finding that, where it's not a competitive thing, and working together to kind of fill out the repository of chemical hazard assessments for those alternatives. We're not really focusing on hazard assessments for PFAS because we already know we should move away from that. But yeah, focusing on the alternatives. Okay. Oh, there it is. So this is a quote from one of our founders, Dave Packard. So as you can see, we really believe the betterment of our society is not just a job to be left to the few, it's a responsibility to be shared by all. So that's where everybody is doing their part and working together to move in the same direction. So thank you for your time, and yeah, I look forward to the roundtable session where we can share more about best practices and challenges and solutions. So thank you.